Okay, so we're talking today sector of a circle. It's like a slice of pizza. So you have two radii, and it's the whole piece of the circle between those two radii and the edge of the circle. We call that the sector. To find the area of that sector, it's very similar to arc length in that you want the area, the measure of this arc divided by 360, which gets you the fraction of the whole circle you're talking about. But now instead of multiplying it by the circumference, you would multiply by the area of the whole circle. So fraction of the circle you're talking about times the area of the whole thing. So then we did a practice problem. I just made a really big sector. Okay, so if you want to find the area of this entire shaded region, I would want the measure of this whole arc here, which happens to be 240, right? Because remember the whole thing's 360 minus 120. So I get 240 over 360 times the area of the whole circle, pi r squared. And then we do our math. We have an exact answer, 200 over 3 pi meters squared, and then we round it to 209.4 meters squared. Now, we're talking about segment of a circle. So a segment of a circle is when you draw a chord, and it's the area between the chord and the edge of the circle. So this whole shaded region is referred to as the segment of a circle. So to find the area of this piece, you have two steps. First, you're going to turn it into a sector. So we drew in a radius to each, chord endpoint. So we turned it into a sector. So I want to find the area of this whole slice of pizza, and then I'm going to subtract away the area of this triangle. So those are your two steps. Area of the whole sector minus the triangle. So that's where we're at. We just started the number one, finding the area of the whole sector. So area of a sector is measure of the arc, which would be 100 over 360. And I would multiply it by pi r squared, the area of the whole circle. Pi times my radius in this case is 10 squared. Okay, so if we do this math out, that would be 10 over 36, 5 over 18, is that right? Times pi times 100, and I could reduce those two. Did you guys get 250 over 9 pi? Yeah? Okay. So there's the area of my sector. I'm not going to turn anything into decimal yet. I'm going to leave it as it is. Now, from this answer, I need to subtract the area of this triangle. Okay. So how am I going to find the area of this triangle?
You make a draw radius.
Yeah, so basically, remember that this is an isosceles triangle. So if that's 10, so is this. And then I can drop an altitude here. That altitude will bisect that angle, and it'll also bisect this third side. So when I draw that, now this is 50, this is 50. Sorry, it's a little messy. And that's 10, and I'm trying to get, 1/2 base times height. So I would love to get these two sides. And I can using trig. Unfortunately, it's not a special right triangle, but I can do it. So let's go ahead and find this side first. So let's see, that would be sine. So I would do, let's see if I can fit it in here. Sine of 50 equals opposite x over hypotenuse 10. Yep.
May I please use the method?
Sure. Here we're going to have to round because sine of 50 is, this would be a nightmare to leave it in exact. So 7 point, let's go 2 decimal places at least. 7.66. And then I do still need this height, So then I would use cosine. Adjacent over hypotenuse. So cosine 50 times 10. 6.43. So now I can find the area of this triangle. 1/2 the base is 7.66 times the height 6.3. Yeah? So the area of this triangle, 1/2 times the base, 1/2 the base is 7.66 times the height 6.43. I have, 49.25 for the area of my triangle. Everybody agree? You're getting the same thing I am? All right. So, minus 49.25. So now, let's go ahead and figure out what this is. Yep. Because I need it. Remember, you can, but then aren't I taking half the base anyway? So I just kept that times that. But you're right. You really are doubling it, but then you're just going to take half anyway. So now I'm here. If you do this right, you should not get a negative number, right? Because this whole area minus the triangle should not leave me a negative. I should get some positive value for this. So let's see what we get. 250 divided by 9 times pi minus 49.25. 38.02. Meters squared we're in. Did you get what I got? You did? Cool. Shall we try another? I knew you'd be up for it. Let's try this one. I'm going to try and make this one tricky on you. What if the segment was all this? Yeah. So what I would do in this case, I would find the area of this and subtract it from the area of the whole circle. Wouldn't that be easier? I think so too. So, let's say, I don't know. Let's make this a 4. And let's make this a 120. So you're looking for the area of the entire shaded region. Oh, this one's tough. Or is it? I don't know. It's kind of hard to see, isn't it? Sorry. I guess I made too many squiggles. Can you tell that that's a 4?
Yeah.
And that's a 120?
Yeah.
Sorry. I think I just made it worse. So here's my game plan. I want to find the area of the unshaded and subtract it from the whole circle. So in order to find the area of the unshaded, I need the area of the whole sector minus the triangle. Oh, and we can throw some letters on here if you want. Oh, let's call this center point D maybe. When we talk about the sectors, usually we just call it sector and then whatever the angle is. ADC. I'm going to redraw my triangle down here and make my life easier.
Wait, but you don't have to do that.
I don't?
No, you don't have to do any of that.
Why
You
not?
just use the original equation. Oh, that's a sector. Never mind. Ignore me.
Are you guys getting the same thing I am? Or what? I don't know if you're looking at mine yet. So I found the area of the whole sector, 16 over 3 pi. Do we agree there?
Oh, I thought you wrote 128.
And then I just found the area of the triangle, 4 root 3. Let me know if I've lost you. Did I lose anybody? You getting what I'm getting? All right. So now I need the area of the unshaded region. So I do sector minus triangle. So I now have the area of the unshaded region, this little wet pizza crust right here, but I need the area of the shaded region. So remember, the original game plan was to find the area of the unshaded, which I did, but I need to subtract that from the area of the whole circle now. So I just need the area of the whole circle, and then I'll minus that from it, and I'll be done.
Would you just write that as your answer? 16 over 3 pi minus 4?
Well, it depends. If I ask for an exact answer, well, that's not my final answer. I don't like to round to the very, very end, so I'm going to leave everything in exact until the end, if I can. So, area of the whole circle, that's just pi r squared, so that would be 16 pi. So, the area of the whole circle, so whole circle minus unshaded, that would be 16 pi. Now be careful, you have to minus this whole thing. So it's really minus 16/3 pi plus 4 root 3. Right? Because I'm subtracting the quantity. So that's my exact answer. And then I could throw this into decimal form and hope that we don't get a negative, because that would be bad news. I should actually get a pretty decently large number, because the shaded region's a big part. 16/3 pi plus 4 root 3. Ah! Well, that's never good. I got a syntax error. Okay.
Becomes that's like 40.43.
I can't even get out of it. Oh, God. What was your answer?
40.4.
Oh, okay. Hold on. I gotta retype it. Oh, God. What's going on? I can't stand these. I only know how to use graphing. These throw me for a loop. Plus, I think because I didn't get out of my square root correctly. Yeah, 40.4? I agree. Did you get what I got?
Yep. Yes.
So this is a beast of a question, but it's doable. So 40.4 if I'm going to round meters squared. So this is my exact rounded.